So since we took the Unit 2 test on Friday, we're going to start Unit 3 today. Unit 3 is going to deal with polynomials and polynomial functions. A polynomial is just a grouping of terms in a single variable. And so that part's nice. Most of them are going to be single variable, but some of them can be multiple variables. Okay? And we'll get to some multiple variables yet today too. And dealing with them. So like today we're going to talk about exponents and exponent rules and scientific notation. Tomorrow, we don't have class. Wednesday, we're going to talk about end behavior of polynomial functions and, you know, odd and even polynomial functions and that fun stuff. Thursday, we're going to add, subtract, and multiply polynomial functions. So we got all that stuff going on. And then next week, we really only have class next week, Monday, because on Wednesday of next week is a half day. And then, so I'm still debating. I'm debating because 1.5 classes of the 3 meet. So we might do something and then just watch a video, or I don't know. We'll figure it all out. Okay. So today, we're going to use properties of exponents in scientific notation. Okay, let's get into it. So I am going to tell you the fact that x to the 4th power, and that's how that's read. It's not read x4. It's read x to the 4th power is equal to x times x times x times x. Okay? With that being said, that x to the 4th power is x times x times x times x, I would like to see what you remember about exponents by doing these 6 problems. Okay? Go for it. I want to know what you remember, not what she remembers.
Sorry.
Jeez, Rod.
So this first one is x to the 7th power. Second one here is 8 times x to the 6th power. Third one here is x to the 5th power. Fourth one is x to the 8th power divided by 9y squared. Fifth one is x to the 12th power. And the last one is 1 over x to the 5th power. Okay? Be honest, how many people got all 6 of them? People got 5. 4. 3. 2. 1. None. Okay? Some people are choosing not to participate. I get it. Okay? Right? So let's talk about the laws, the rules, the exponent properties, if you will. Okay? These you should star in your notebook because these will come back throughout the entire year. Okay? We never get away from properties of exponents. Okay? So the first one is when you have a base, and that base has a power to it, and you're multiplying. Okay? So you've got a base, and the kicker is that this base right here has to be the same. Okay? So those bases have to be the same. If those bases are different, then this property does not apply. Okay? Those bases have to be the same. If that's the case, bases are the same, then what you can do with your exponents is you can add your exponents. when we have a power, the second one is called a power to a power, where I've got a base with an exponent on it, and then I'm taking that whole thing to another exponent. That's called a power to a power. And what happens here is we multiply the exponents.
Beautify select the coefficient already. Or like A.
We'll get to that one. I got one down. It's number 6, where we'll talk about that. But yeah, because I wanted to talk a little bit different, because I do that one a little different. Okay, but yes, it would also apply, like in number 2 that we just did on the last slide. Okay. Third one is if we have a fraction. Okay, so, and again, the kicker here is that we have the exact same base. Okay? If the bases are different, this does not apply. Okay? But the kicker is that we have the exact same base. And if that's the case, then we subtract the exponents. And it's always top minus bottom. Always top minus bottom. Fourth property is that we do not accept negative exponents ever. Okay? We want all of our exponents to be positive. And by we, I mean us collectively. Okay? You should not settle for a negative exponent. Okay? So what we do with that is, if I'm thinking about this as it's over 1. Okay? So we move a negative exponent from the top to the bottom to make it positive. So then this would become 1 over a to the positive m power. Likewise, if we had something, and I'll go a little more complicated here. I'll throw an extra term in there. Okay. If it's negatively exponented on the bottom, we move it to the top in order to make it become positive then. So this one would be a to the positive n and then times b. We don't move them both unless the whole thing is in a set of parentheses and there's a negative exponent on the outside. Okay. Then we would move the whole, we would flip both.
And that would be A with an exponent and over B. That's the case.
Yes. So like if we had, so I'll go a third one here. So if we had b over a to the negative p power, let's say, just like my variable, my exponent is different, then that would be a over b to the positive p power. Property number 5 says that anything to the 0 power is 1. Any number to the 0 power is 1. Any variable to the 0 power is 1. A toaster to the 0 power is 1. Okay? Anything. And our last one was the one that Emilian was talking about before. What if we have multiple things going on with it? Okay? And it's like the distributive property when we've got powers to, with other powers to powers, but it's just into the exponents. So this particular one, as written, would be A times B to the MR power times C to the NR power. Because the A is not in the set of parentheses. Now, if I rewrote that so that the A was in the set of parentheses, now that A is being controlled by that exponent, so it would also get it. In the first one, the A is outside, it's not being controlled by it. In the second one, it's inside the parentheses. Now it's under R's control. So now it also is. Questions, comments, concerns about the properties of the exponent?
So M was like 5 and R was 2. Here, it was
So it'd be B to the 10th power. Mm-hmm. All right, let's try some. Try those two. Give you a couple of minutes here to try those two. Okay. So this is going to be like 2. Oops, tap the brakes. This is going to be like 2 to the 3rd power, x cubed to the 3rd power, y squared to the 3rd power. 2 times 2 times 2, because that's really what 2 to the 3rd power means. 2 times 2 is 4, times 2 more is 8. Wait. It really is, I promise. Okay? X to the 9th power, y to the 6th power. Yes? Okay? Now, there's a couple of different ways to apply or to do number 2. Okay? One way is you could subtract the exponents. One way is you could make them be positive exponents and then subtract the exponents. Okay? Another way is you could make them be positive exponents and then say to yourself, self, are there more x's on top or are there more x's on the bottom? And how many? Okay? Either way, you get x to the 4th power. Okay? Try those 4 now. So this is, I really don't need to use the parentheses on this first one. So we have 2 times x cubed all over y to the 4th power because it's got a negative exponent. So we move just the y to the 4th power to the bottom. Times negative 3x squared all over y squared because, again, have a negative exponent. So that term just gets moved to the bottom. What?
Wait, never mind. I got it.
Okay.
You don't? Okay, I'll ask for Jenna.
Okay, go ahead.
Are you asking why he's putting him over a bar? I don't know.
Well, do you agree that there's negative exponents in this particular problem?
Yeah, I realize.
And we don't like negative exponents, right?
Yeah.
Okay. So the term that has the negative exponent gets moved to the to the opposite side of the fraction bar. Okay? So when it's just written out, it's all over 1, so that's why y to the 4th got just moved to the bottom. And only that one. That's the only. Then it becomes positive. Okay? So now when I multiply across, I get negative 6x to the 5th power all over y to the 6th power.
Can you look at the way that I did it?
Did you get the same thing?
I don't know. Can you get it?
Did you get the same thing or not?
Kind of, sort of, not.
We got negative 6.
You just, I put mine all as 1. You have yours as 2.
Right, so
Yeah.
that's good, right?
No,
Okay.
no.
Oh, I thought I
Huh? Next one. Okay? Negative exponent controlling the whole thing. But now I've also got a negative exponent inside yet, too. So this is like 1 over 4 cubed m to the negative 2 power cubed n to the 4th power cubed. So then this would become m squared cubed all over 4 cubed n to the 4th power cubed. So I would get here m to the 6th power on top, 64 n to the 12th power on the bottom.
So what you did there is, what's the green part?
The green part is I broke up, I applied the power of 3 to all of the parts of the parentheses.
Right. And then
Okay.
how'd you get m squared to the 3rd? on
Yeah,
top?
how do you get
Because
that?
the m,
Oh, you're getting
it's
rid
because
of
it's a negative exponent, so
Right.
we move it to
To
the
the
other
top.
side to make it positive.
Alright. I can give him that.
It's just
First step is what?
Take the 8c, put it on the bottom.
Do I put the 8c squared onto the bottom?
Take the c squared, and put it on the bottom.
Just the c squared is all that's being controlled
so
there.
then it becomes positive.
So it becomes 8d cubed on top, 12cd to the 4th power, and then that c squared from the c to the negative 2 power up top comes in. Right? And now we just simplify. So with numbers in fraction form, we just simplify the numbers like we normally would. 8 can be divided by 4. 12 can be divided by 4. Are there more D's on the top or more D's on the bottom? The bottom by how many?
1.
1. So this goes away, and that leaves me with a D down there. Which means then, on top I have 2. On the bottom I have 3c cubed D.
Wait, why is it cubed?
Because of
Because
that.
there's a C right there.
But why is it cubed?
Because there's 2 right there, and there's 1 right there. That means I got 3 of them.
I got it.
She said, but why is it cube?
I didn't
Why is
realize
it cubed?
you putting them together.
Yep. We want to be as pretty as possible.
You just combine like terms there. Right, sort of.
Why did you put 1? No. Oh.
Oh, because there's 1 more on the bottom.
Yeah,
Yep, so it's gone.
I messed up.
Okay?
Like I'm doing a lot of learning right now.
So this one should be negative 3 cubed x to the 4th cubed all over y cubed cubed. So that's going to be negative 27 x to the 12th all over y to the 9th.
Oh. I should write this down.
Right, so you can have a negative number. but
We
you
can
don't-
have negative numbers. We can't have negative exponents.
So you just Let's start by district, okay. Wow.
Go ahead, talk it through. -3 cubed is -3 times -3 times -3,
Whoa.
which is -27,
And then you do 4 times 3.
which gets me
you
to 12,
Okay.
and then 3 times 3, which gets me to 9.
Okay.
Yep.
This is so good.
So basically, you just simplify
And
Yep.
throughout the entire thing. It's never like you're solving.
Can't solve anything, there's no equal sign.
But,
You understand what I'm saying, Bugsy?
yeah.
Yeah, no equal sign, can't solve anything. All right, let's talk a little bit of scientific notation now, because scientific notation is a way to write really big numbers and really small numbers all at the same time. Okay? So, a couple of things about scientific notation. Okay? So the first rule of scientific notation is that there can only be one digit, and that digit has to be between 1 and 9. It can't be 0. Okay? There can only be one digit to the left
Sig figs.
of the decimal point. Now, we are not dealing with sig figs. Okay? That's for science.
Oh.
Okay?
It's not coming.
Okay? We're just doing straight up scientific notation. Okay? So what I mean by that is, if we had the number 72,000, right there's my decimal point. Okay? I've got 5 digits to the left of the decimal point. Okay? So this would become 7.2 times 10 to the 4th in scientific notation. Now there's only one digit to the left. Okay? Now, the second part is that there are 2 parts to every scientific number. And we deal with those parts separately. Okay? So the first part is the actual number part, like the 7.2 over here. Okay? That's the first part. Okay? So that part, we're going to be multiplying and dividing scientific notation numbers. So you are going to multiply or divide that number. The second part is the exponent. And you are going to add or subtract the exponent, depending upon, if you're multiplying, you would add them. If you're dividing, you're going to subtract them. Okay? Now, scientific notation is the only time that we accept a negative exponent. Okay? That's the only time we accept a negative exponent is in scientific notation, because those are really small numbers. Okay? And then we have to adjust our number depending upon how it looks and how we get it back into one digitness form. Okay? Let's try 2 of them. Okay? So the first thing that I'm going to do, let me scroll back down just a little bit. The first thing that I'm going to do is I'm going to take the two number parts and I am going to do whatever it is that we're doing with them. In this particular case, we are multiplying those two together. So somebody with a calculator, please, tell me what 6.8 times 3.6 is. 24.48. Okay. So 24.48 is what I get when I multiply those two numbers. Then I've got a times 10. And now I have to deal with the exponent part. So the exponent part says I do what with my two exponents? I add them together. 2 plus 8 is 10. Okay? Now,
There's a problem.
what's the problem?
There's more than one.
More than one digit to the left of my decimal point. So I've got to move this decimal point one spot over. And when I move that decimal point to the left, I'm going to add 1 to my exponent. If I move it to the right, I'm going to subtract 1 from my exponent.
And we still include the other shit.
And we still include the other things. So this, in its final look, would be 2.448 times 10 to the 11th power. Okay. A divide problem. Same thing. First I deal with the numbers. So I'm going to deal with these two numbers first. What am I doing with the numbers? I'm going to divide them. 9.3 divided by 3.1. Don't even need a calculator. What do you got? 3.
Yeah, come on, Rod.
Don't act like you didn't have that on your
Rod, come on, bro.
Times 10 to the, and what do I do with my exponents?
Right.
Subtract, because that's the exponent rules from before. We subtract top minus bottom. 16 minus 4, 12. So this answer, do I need to adjust it at all? No, sometimes we get lucky and we don't have to adjust it at all. Good?
Yeah.
Awesome. I would like you to now try one more on your own. So those two multiplied together, I get 1,201.56 times 10 to the 64th power. But I have to adjust now, correct?
3.
So I got to go 3 spots to the left, which means I've got to add 3 to my exponent. So I get 1.20156 times 10 to the 67th power.
We did it.
Yes?
Yeah.
Love it. On the purple worksheet for this week, week 7's worksheet, purple worksheet, you can do numbers 15 and 16.
Right now?
If you want.
Thank you.